So, welcome to this short presentation about hardware hacking stuff. We would like to present you our framework called Hardsploit, and Hardsploit is like a bridge between hardware and software pen tester. First of all, who we are. I'm Yann, Allain, the CEO of Opal Security. I'm a black hat, hacking the box, something speaker and trainer. And I'm a cybersecurity veteran because I'm the old guy in the team. And I'm the former chief security officer of Accor, a big company in hotel domains. And Julien?
Hello, I'm Julien. I'm electronic engineer at Opal Security, a French company. And I'm a security consultant, and I create Hardsploit project. And today I try to explain you what it is.
So, Opal Security in one slide. We do some training, consulting, and we made some products because we made our own product like Hardsploit. And our DNA is based that we do some security in IT and in IoT, so Internet of Things security. So, Internet of Things, there is some privacy concern, security concern, because as you must know, any IoT object could reveal information about their user, about the IT system they are plugged into, etc., etc. As we are in Hacking the Box, we don't lose our time with these marketing slides. However, the main idea is that Internet of Things could be the new playground for hacker, and you can change this slide every week if you want. And every week we have some trouble with IoT hacking or IoT security in the news. This is our view of 20,000 feet view of IoT system, the big ecosystem. There is a few main parts. First, this is the electronic device. There is a communication channel, wired connection or a radio frequency connection, and there is something in the cloud, as everything needs to be in the cloud. And our system aims to be able to do some stuff with electronic audits, so only it works on this side. So, from a security speaking, we think that hardware could be the new software. Because in IT system, there is a lot of security functions that are already available on the offensive part and on the defensive part. However, in the hardware, there is few security functions that are available for all the IT ecosystem and people doing stuff with IT and IoT security. So we decide to create the tool called Hardsploit to let IT consultants to be able to do some security audit or security pen test in the IoT world without the need to be electronic engineer. So we have created the Hardsploit framework to become a bridge between software pen tester and hardware pen tester. So this is the only speaking part of the conference, and now Julien will make some demonstration about Hardsploit and how it works. Julien?
So the first step is to open the system. In this case, we try to audit this. It's a fake log system. When you put a code, you have a green light when it's true and a red light when it is wrong. It's just for training purpose, of course. And so the first step, you need to open it. It's okay. The second one is to fingerprint all the components. Is to obtain some information of the ships. You can read the name, etc., etc. And after that, you need to find the chips with very sensitive data, like microcontroller with flash memory, external flash memory, or EEPROM, etc., etc. So the next step, of course, is read or write or do something with this chip. And after that, reverse engineering if needed. the goal today is to demonstrate a tool to help you to extract some information for this step. With Hardsploit, you can read and write, and after that, you need to try to reverse with some classic skills. So, oh, sorry, I have a big book. So the goal, of course, is to dump all the data on a system, because you have some keys, sensitive data like a log or whatever, something not encrypted or it is depend on of your system. Is not the goal today. The goal today is just to demonstrate how to extract the data. Just for example, in IT system, you have some or electronic devices. When you want to communicate machine to machine, you need some buses. I don't know if you know all these buses, but it's not very complicated. But when you don't have any tool to read this data, it's not easy all the day. So you need to try one tool for one bus and another tool for another one, etc., etc. So you spend your time. And in my company, it's our job. So we have a limit, a short time to do an audit, and you need to focus on the vulnerability and not on the extraction of the data. So the goal is to have a framework to interact with all these buses with a very easy step, 1 or 2 steps. So. And by a graphical interface to avoid some trouble with command line, etc., etc. Just to understand what is Hardsploit, you have Hardsploit with a database like Metasploit. It's for that the name is like Metasploit. You have a database and you put some technical information like speed, it depends of the bus. And when you have a big database, you can just read in fingerprint step, just take the name and put it on the graphical interface. And after that, you need just to click on one button to extract some data. It's a goal of Hardsploit. And after that, you can choose your bus, and you have 64 input and output, and after you have your target. So why we have 64 input output? It's because when you want to interact with parallel buses, I don't know if you know that, but you need to put about 20 or sometimes 30 bits to create the address bus. And you have some bits for data, sometimes 8, sometimes 16, and you have some cable for the control. So most of the time, when you want to read a parallel memory, you can find this memory on router, for example. You see a slide at the end of the demonstration with the parallel memory. I'm sure you you need to put very lot of cable, and you need to generate a lot of signal to be able to read the content. So Hardsploit can do that. And after the wiring, you need just to put one button to read all the contents. It's for that we have a lot of input and output. And you can imagine a lot of things, because it's based on FPGA. So you can create what you want. If I want 3 SPI in the same time, for the moment it's not possible, but because we need more time to add this possibility. But for the moment it's just HUC and after that SPI, etc. But we can imagine we can try 3 or 4 HUC in the same time, or what you want. It's possible. It's a framework, and you can change what you want. The next step of Hardsploit It's the same, but we add a scanner database. So, for example, if you have JTAG or some specific chips, you can, with the scanner, like Metasploit, you can find some exploit, and the goal is to put all the wire on your target in the wrong way, and just put the button to find it. And after that, you can extract all the data. It's possible on JTAG, serial wiring debugging, and maybe in SPI, but and E2C, but SPI is dependent if the flash or something like that. And the goal is to try all the possibility and find your data with a very simple way to do that, because you have helping to patch a wire and just one button. Sorry, I can do better. It's not possible to do better. It's the goal of Hardsploit in the next step. I don't know if you know Bus Pirate or something like that. If you want to see what is the difference, Bus Pirate is a very good tool, but too old, I think. And you can process parallel memories because you don't have more than 10 wire. You don't have any graphical interface, not exactly because the community create your some script and etc., but it's not native. So, and it's based on a microcontroller, so you can't change anything in microcontroller except the code, but you have a hardware limit, and I think it's not enough today when you see all the IoT system. You have the regulator. It's good tool, but it's just used to identify some wire, and you can interact with. You can't interact with your JTAG or something like that. If you want to find the wire, you can, but it's enough. You can do more. So it's not my favorite tool. You are good fit for SPI. It's not a bad tool. Yes, it's a good tool for that, but only for SPI or JTAG. It's too limit. You have two more limits for security audit in hardware. You don't have always SPI buses. You can have a lot of more data in SPI, one wire or something like that. You need to have a platform more powerful. And you have Hardsploit based on FPGA. So of course we can change a lot of things. I don't know if you know FPGA. It's different like a microcontroller because it's very low layer. It's like a NAND, and it's the level of gates. So you can only create a logic logic things, and you are very low, and with that you can create your own state machine with to process more protocol and etc.
In fact, what we want to create is exactly the same that the Metasploit have done with software. We need to create exactly the same platform, but for hardware hacking. So with FPGA, you will be able to create your own VHDL module, like you can create your module in Metasploit, but you need to understand VHDL. It's quite complicated.
And my favorite part of Hardsploit, it's the wiring. You understand after why. In audit, when you want to audit security, when you want audit hardware, you need to patch wire because it's real life. You have a real board, and if you want to extract, read, or whatever, you need to put wire on the top of your system. But your tool, like Buzzparrot, it's not easy because you need to read some datasheet to understand where you need to put a wire, etc., etc., and you lose your time, and I don't like it. So for that, we create Hardsploit with 64 LED. Oh, sorry. And I don't here. And we have a demo just after, but when you click on your signal, you can see where you need to put the wire. So of course, for E2C, you have only 2 wire, okay. But when you want to wire a parallel memory with about 30 wire, it's very interesting system. I'm done. I don't know if you are interested by the internal processing of Hardsploit, but
Just who is familiar with electronic design and electronic stuff in the room? Okay.
okay.
More.
We have a PC with a graphical interface, and we connect by a microcontroller for the USB processing. And after that, we connect microcontroller with FPGA by 2 SPI, and another SPI to program the FPGA. And inside the FPGA, we create each state machine to process E2C, SPI, SWD, one wire, UART, etc., etc., etc. And each time you want to use buses, FPGA is programmed by microcontroller by your GUI, and it's easy. Just click on the button, and the FPGA change the behavior. Just to explain how we create Hardsploit, the first step.
We are a small company,
Yeah, very small and
but efficient.
I don't know if you know the process when you want to create your own board, but it's not efficient, but it works sometimes. You have a stencil. You need to put this on the top of your PCB and use some tool, and you can put the solder paste on the top, and you can remove. But you need to have a very, very good accuracy to do that. And of course, with Scotch, it's not possible because it's not very accurate on the top of your desk, and etc., etc. So we need a more efficient tool. After the stencil, you need to solder all the components. Of course, it's not possible to do that for each LED. 64 on each board, etc., etc. It's too complicated. So after that, we create the homemade oven, reflow oven, with custom PID for the oven.
And just to mention that we are a very secure company. There is a bottle of water just behind this. This system is directly connected to the electricity.
After that, we need to buy some best tool to do that. Professional stencil tool. It's more accuracy. You can obtain more accuracy with this tool. You have a pick and place machine on the middle. Is to take some component on the reel, and you can put it on the top of the PCB very fast, faster than me. And on the right, you have industrial reflow oven. When you press the button, you have about 100 degrees in less than 2 seconds. It's better. So you can see the final version of Hardsploit, because the hardware is the hardware, and you can change the behavior of the hardware by code because it's FPGA. So it's for that we change the software on yesterday, tomorrow, and all the day, but the hardware stays the same. So we have ESD protection. We can use Hardsploit in 3.3 volts and 5 volts. We use Cyclone 2 from Altera, and we have USB 2 to connect the board and raw program, etc., etc.
Just to mention before how the tool work. There is main part. There is the hardware part and the software parts. Software GUI you will see in a moment, and software API to connect to the board is open source, so you can change it, you can modify it. You have the ability to create your own modules in VHDL.
Yeah.
So you can use this board for your own needs.
Yeah.
You don't need us to be able to let us have time to make some specific VHDL modules.
Yeah. I provide you a template for Altera Quartus toolchain. I don't know if you know, but it's a toolchain for this FPGA, and you can just click and you have a template and it works perfectly. So you need to put your VHDL code to do more.
So the board is closed source, main. The API is open source and the GUI is open source. And if you want to hack our system, you can hack the Hardsploit board with another Hardsploit board, just for training purpose. Please.
The next main idea of Hardsploit is to remove. I think I want to remove all command line. Not exactly, because sometimes we need to. You need some very lot of stuff on audit, and we need to create something like automatic. So for that, you can use APA in Ruby. So you can create your object of Hardsploit, and you can use loop, etc., etc. It's not a problem. But you don't have any command line for that, because we want to create a graphical interface to be more simple. You plug your board, you start, you click on your component, and you click on dump. 3 steps. You see that just after, and Hardsploit is great for that. But for expert, we want to read, I don't know, 100 times by second or something like that. You can create your Ruby because we publish all example how to use my API, and so you can do what you want without any GUI. You have two projects. APA of Hardsploit and graphical interface in the next step. So it's 2 different projects, but it's the same, of course. But if you want to change anything, you can, because you can base your work on APA if you want. If you don't like our graphical interface, you can remove it. It's not a problem.
Just to make a summary, who prefer tool with only command line tools? And could you raise your hand if you prefer command line tools?
You see? Command line. 50-50, no?
We will see after the presentation if you will continue to use command line tool. You will see. We will make exactly the same question at the end.
But you can. You need just to create and instance your object. So sometimes it's better like command line. So it's more efficient if you use APA than command line, I think. It's not the last, but you have some. Yeah, it's not very good. We have a demo. I think it's better. But the goal, you have a database on the middle, and when you are in the fingerprint step, you obtain some name of your chips, and you can use the search field to find your memory or microcontroller or something like that. After that, you need just to put your mouse on import and export, and one click you have all the content of the memory, and it's enough to obtain information.
And even the CEO of Opal Security could use it.
Yes. And you have a wiring helper, so we see that just after. Yeah, we go on the demo. I think it's better for you now. So, for example, here I have two memories. It's not easy to see it. Yeah. We have one here and the second one just next. Sorry, we have a probe on the top, but you can see. Yeah. It's not a good idea, yeah. And you have a SPI memory, trust me. Yes, it's 25 of microchip memories. And on the middle, you have a microcontroller from ST Electronic. STM32 103 RBT6. Okay.
Just to understand the demonstration,
yeah, it's important.
The board here simulates an electronic lock. If you have button, if you enter the right combination is not English. If you write the right code pin, yeah. There is a green light on the top left of the board, and if you, of course, enter the wrong one, it's a red light. So the goal here is, with the demonstration, is to be able to perform a pen test on the hardware, just to find some vulnerability in the board with our tools. Is that clear for everybody? Who already do some hardware pen testing in the room? Okay, cool. They are competitors.
Yeah. So, for example, for HITB memories. Oh, sorry, it's not very good on your screen. I'm sorry for that, but HITB memory needs some addresses if you want to extract some data on HITB memories. But it's not a problem because we have HITB scanner, of course, on Hardsploit. So you can see your data sheet and check your board, and you can obtain this information if you look at on the top of the memories. But it's boring. I prefer use automatic tool. So for that, you can start. Also, I need to plug my board before, it's better. Yeah. It's better. So we upload the firmware in FPGA, and after that we have HITB state machine inside the FPGA. In this case, on HITB bus, we have only one, and we have two memories in a parallel. So we have 4 addresses for HITB because each device have a read address and a write address. So just with one button, when we click, you can obtain all addresses available. So for read, we need to check the first one and the second one. So I think we don't have any time. So trust me, the very good sensitive data, etc., is on the second one. So we try the second one memories. So we set the address here. and we save, but it's default for me, so it's perfect. And after that, I need just to click on export. I can process a small dump if you want. You can start at your address, custom address, and you can choose the length of the dump. But in this case, I want to read all the content of the memory. And all information of the memory is inside settings. You have the size, the page size, the total length. I'm sorry, it's not very good for you. Total size here, page size, etc., etc. This information is on the first page of the datasheet. And the next step of Hardsploit, very soon, you are on internet, a sharing platform. And the goal is when I create some component, I need just to put a right click and upload my component on the internet. And I hope all the people do the same, like Metasploit. It's a goal. But in our case, we need to export some all the content of the memory. We need just to put it on the desktop here. For example, E2C. Yeah, E2C. And full export. I extract all the content of the memory. All is done. It's finished. And after that, I can read the content with Bless, for example, is hexadecimal editor. It's not good for you. Yeah. Amsterdam, and I in the box a very secure password, of course. It's not the goal of today to extract some sensitive data. So the password is here. It's AABC. You can check this on the board. When I put BC, sorry, BC, I have a green light. So I can extract the sensitive data. Of course, it's just for the training, but be careful, because in a very real case, we can extract some sensitive data like that. It's true. Okay? So, yes, it's just a demo, but not exactly a demo. For example, if you want to change, I want to change a password, I can change directly the information in the file. For example, I change A by B, and I save. And, sorry, I take the file on my desktop. Oh, yeah. Oh, yeah. It's not a bin file, it's for that. So after that, we can read again to be sure. For example, the write is done, just to be sure. So I erase the file. I export again. Okay, the password seems to be changed. A, B, B, C. It's not easy for you. I'm sorry for that. So we try. So reset the board. I change by very A, B, B, C. Okay. So it's a password inside the memory. You can change in a couple of minutes, less than a couple of minutes. So now, if you are a software pen tester or a very good expert in hardware and you don't want to spend your time on these things, you can use Hardsploit. I'm electronician. I know all these buses, but I love Hardsploit for that because now I can focus on vulnerability and not how to extract the data. At the beginning, I need some time to create my tool. For example, for parallel memories, you need some time to spend your time 3 or 4 days to create all the addresses, etc., etc. Here, you can read and change and rewrite again in less than a minute. So I think it's a very good tool for audit. Of course, it's work on SPI, SWD, etc., etc. I think I have 1 more minute because it's enough for the demo. I have a microcontroller and I want to read the content of the microcontroller. Most of the time, a microcontroller contains source code, not exactly, optocode and assembly code, and you can extract some custom protocol or something like that. It's very important for the company. If you can extract the firmware of microcontroller, you can take it and put on a clone or something like that. You can reverse engineering the firmware, etc., etc. So for a company, it's very complicated if somebody can extract the firmware. In some case, if you forget the flag, a secure flag, a readout protection secure flag, you can extract the firmware of microcontroller like now, and just like that. So maybe it depends if it's a good wiring. No, I need to just swap a wire. Yes, my target is detected, and just after that, I can use export like SPI, E2C, etc., etc. For example, firmware.bin. Dump is finished, and if I read the content, I can obtain all firmware of microcontroller. And if you don't trust me, you can see all string of the microcontroller because it's a training board for our training, and we have a lot of a telnet connection, etc., etc. So we have a string to print on the console, and you can see the string in the firmware. So you can put this firmware in ADA Pro or something like that to reverse the firmware. So in less than 1 minute, I can extract the firmware if it's possible. I can change it, etc., etc. Hardsploit is a bridge between hardware and software. After that, you need just to reverse engineering. It's not the easier part, but before you need to read the content and have the data. Yes, just some, yeah. For example, if you have, if you want to wire, if you want some help to wire the memory, you can use a helping wiring module. So if I take the board in the good way, I can see the same chip on my board, a real board, and I can see this symbol on Hardsploit. If I click on E2C clock and I go on the camera for you, I can see the first LED here, and I know I need to put E2C clock here. After that, sorry, SDA, it's the same thing. It's the second one. It's not If you don't trust me, you can go here to verify one by one. Yeah. Of course, for E2C, you have only 2 wires, but trust me. For example, yeah, maybe it's better for you here. If you need some help with Hardsploit, you can, because you have a lot of, in this case, I think 32 bits and cable. So if you have helping, it's more efficient, because each time you click, each time you see where you need to put the wire. In this case, is here. Yes, it's not easy for you. Yeah. Etc. 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 And I have another demo, but not today in live because it's too complicated with parallel memory. But for example, if you want some a number, I know all the people like the number. For E2C, all is supported by SP2. You can up to 25, but 50 works perfectly. SWD and GPIO interact. For the next step, we have GTAG, one wire, etc., etc. It's just the beginning of Hardsploit, and it's based on FPGA, so it's not a problem. You have exactly the same hardware, and we need just to change the soft.
And you can create your own module
if you want.
Send us your module to be imported in Hardsploit, because it's a framework for the community. So, for example, the sharing platform is, I think, is available soon. It's not exactly 30%. Now we are more like 80%. For bus identification, yes. Scanner, yes, it's 30. And a lot of things. UART is done in our next beta version, not this version. We changed a lot of things. Better API, better code source, and I want to bug also.
better bug, yes. We had E2C sniffing and SPI sniffing in the next release, and we have these things available for NRF24. It's already available because we need this to drive some drones. Because when you provide trainings at your training session, we create a new exercise. It's to pawn and you hack automatic drone. I don't know if you see our video, but in your next training, you learn how to hack. How to audit, and after that you try all these things on a very real system like automatic drone. I create a system to have a takeoff and landing automatically by soft, and the goal is to explode, burn, or what you want the drone by wireless, by dumping firmware, etc., etc.
In fact, it's a capture the flag challenge at the end of our hardware hacking trainings. But for that, if you want to see it, you need to register to the next Black Hat in USA.
Yeah, if you want.
And take an airplane ticket.
So it's for that. NRF, is already available for that. And Metasploit integration, I don't know. Maybe we can ask you what you.
What do you think about that? Because we are not sure at the moment. Do you think it's in an interesting way that the Hardsploit, not GUI, but the Hardsploit API will be included in Metasploit? Is it a good thing for you or not? Who think that it's a good thing? Just one people, two people? Okay. So you need to we need to develop only for you a specific parts. I think I hope you have money.
And of course, hard CAN bus, etc., etc. If you have any idea, don't hesitate to to email me or put this on GitHub. Of course, it's community, so it's for that. It's okay for you, you understand. And for example, if you have a router, you need...
It's just for photo purpose.
Yeah.
It's not a real one.
So I hope all the people in this room know this router. Yeah, of course. So in this case, if you want to extract the firmware, you can go on the website. It's sometimes it's better. Or if you have Hardsploit, you can desoldering the memories and put all the wire on the memory. It's not very easy directly on the top of the board, but you can create your own custom reader like that, or use this type of tool, and you can plug all the wire by Hardsploit. So in this case, you understand, because you understand, I hope, why I create the wiring helper, because I have a lot of wire, and if you swap just one wire, so swap 2 wire, it doesn't work. You can't have some very good firmware. So you need to put all the wire in the good way. So it's not the very fun part, but you can do that with Hardsploit. And you can, in this case, extract the firmware here.
So I think we are near the end of the session. This is our tool. This is a new project. We need your feedback. You can modify or ask us to modify something in the GUI or in the API. And I would like to thank you for coming to this session. And this is time for QA.
Many vendors today implement things like checksums and even encryption in their firmware. Do you have modules where you can, once you figured out what they're doing, automatically recalculate and decrypt, encrypt on the fly in your graphical interface?
It's not the goal of Hardsploit. For that, for example, you can use binwalk. But yeah, exactly. Yes, exactly. It's a good idea, and to be honest with you, it's not the goal for the moment. Yes, but it's a good idea. I hope if all the people like this project, I can use OpenOCD, I can use binwalk, etc., etc. It's not complicated to enter to send a firmware in this tool. So yes, but it's not my job to create this for the moment. It's just to have a good platform. But if I have the time after that, maybe I can contribute on binwalk or a tool like that. Yeah.
But you can create your own modules to put this module inside the FPGA of Hardsploit. We have an API for that, so you can try.
Your API will make it pluggable to just say, well, this firmware for this thing has a checksum, and I can just add my checksum module.
Yeah, just is the next of, yes, you can. Yeah, it's possible. Yes, you need to understand the API, but it's easy. I think you know that. Yeah, it's possible because it's just a Ruby object. So you instance, you get the firmware, and after that you can put it on your custom module. Yeah, it's possible.
We have another question right here. Yeah, how big is the current database of supported chips?
Depends on your upload in the sharing platform.
Sure, but I think you have a few right now.
Yeah, so for the moment, no, we not exactly this, because we keep some device in our local
not
application.
public, yes.
For the moment, it's just the beginning of Hardsploit. We need to finish the sharing platform for that, And after that, I publish all things I have. And it's like Metasploit. At the beginning, you need. It's very complicated to extract data on datasheet. It's just the first page, but you need just to put some information on a few fields. If all the people of this room create one component, maybe we have 100 components in 10 minutes. So we have 10 components, and those components are very useful components that you will face everywhere in pentest, because these components are those that we are used inside our own hardware pentesting.
Sure. I see some of the components I recognize, but what I'm wondering as well is if you have a chip that is not supported, but you know the I/O.
Yes, you can trade directly on the graphical interface if you want.
Okay, but can you also like enumerate? So it's, let's say it's I2C, but you don't know the pin layout of the chip. Can you actually enumerate and find the right chip automatically?
Yeah. Okay.
I don't think you have to set it manually, right, in the interface?
For the moment, automatically. But for example, a memory, you can clone, and you can base a new component based on a component inside the database. So, for example, we have a memory with 8 kilo of 8 kilo, and if you want 60 kilo, you can duplicate your memories and just change the size, and it's enough. You have two components. Yeah. Yeah. And after that, you are able to interact with the electronic buses of this company.
Sure, I understand, but you have a sort of different approach to the JTAG relator, for instance, where you can actually say, okay, I know this is JTAG, but I don't know the pin layout. Figure it out for me.
But for
okay.
It is implemented a sort of pin. Yes, I finding automatically. Okay. Yeah. For SPI, it's complicated because you have nothing when you send something. It depends of memories. I don't know. Maybe somebody have a good idea, but my idea for SPI, it's for some flash memories. You can read some ID code of the flash, and for me, for the moment, I think it's the only way to obtain some information of SPI memory. And in this case, I can identify SPI. It's not a problem because I have already implemented the cross wiring, so I can put E2C where I want. So in a loop, I can try all the possibilities. It works, but on my beta version, and I think we have this version in next month. Yeah, it works perfectly for SWD. You put 8 wire on this, for example here. I have 8 wire. I put all the wire and I just put a button and I wait. And just after that, because Hardsploit can read the content of the firmware, it can extract the firmware directly. And if you put a bin walk or something like that just after, you can extract directly the file system, for example. So I hope with you we can create a very good, interesting stuff. Yeah.
Okay. Thank you for your answer.
Yeah.
Hello? Yes. Can you hear me?
No.
Okay. Okay. This should work. Yeah. Now works. Okay. Yeah. Do you have any plan to implement other voltage levels like 1.8 or 1.2?
Yes, it's a good idea, but we have. It's a good idea, but it's not easy because when you use either, you add some impedance, and it's for that in my slide I put 25. It depend in real. It depend of the length of your wire. So yes, but not.
Meaning that you are not even trying to do? You don't have plans? Or?
Yes, I want to try, but I don't have the time. But you can put a translator 1.2 to 3.3 and etc. etc. But yes, it's a good idea.
Good. Good to know.
Yeah.
That's exactly the answer. Thank you.
Any other questions? Okay, well, please warm applause for Allain and Moinard.